Alright, welcome back to part 3 of this video series where we tackle the animation loop cycle, and in this video we are going to continue on with attaching it to the RFL setups. Now in the previous video we had set it up for the heel, so as we run the animation here you can see it's working for the heel. And no matter what I set the offset to, as long as we stick to those milestone points that we talked about in the previous video, whether it be 0, 5, 10, you can see that the heel setup is working for any of these offset setups. And keep in mind, this is only going to work with these offsets, with these milestone points. If I were to do something like 7, this is not going to work. You can see the problem here. You can see it kind of snapping here. This is designed to work primarily within these milestone points. Outside of that, it starts to become a lot more work. So we're going to stick to the milestone points. It'll make this setup a lot easier. So now that we've got the heel all done, now we need to focus on the ball joint and the toe joint. So we're actually going to do the toe joint first. So I'm going to start at the 0 offset. So we're going to bring up the node editor, since that's primarily the rest of the work that we have to do. Now, all of this setup here, this is all that we did for the heel. So we're pretty much just going to duplicate this with making some obvious changes to adjust for the toe as opposed to the heel. But the setup we're going to do is pretty similar to what we have here. Now I want to make a note, because this happened a couple of times in the previous video, that when dealing with connections via the motion path, specifically the U value, I have found that sometimes, even though the connections are correct and all the settings are correct, that the changes don't really take. And the only way to essentially force Maya to make those changes is to actually save the file, like open a blank scene and then reopen that file. It kind of forces Maya to make those changes. It's a little bit of a bug with the motion path, but this is definitely something that we can fix by saving, closing, and then reopening the scene. Alright, so let's get started with the toe joints. So the toe joint is right here, and here are the conversion nodes, and we need specifically dealing with the rotate Z of the toe joint, because that's what lifts it up. So we're looking at output Z here. So this is the output that we need to deal with here. So this unit of conversion can go away, and we're just looking at the output Z. Okay, so with that, what we can actually do is pretty much duplicate the 3 basic nodes that we're going to need. So I'm just going to Control D and duplicate these, and I'm just going to rename these to toe instead of heel. And rename this last thing here. Okay, so we've got the nodes that we need. So let's start setting everything up. And just to refresh, the set range node here is going to convert the certain points of the animation here into the rotation value for the toe joint. The on-off is essentially going to turn it off, and we're going to connect it to this on-off attribute from the original animation loop setup. And the plus minus average node is going to add this new setup into the old setup here. So this multiply divide node is from the kind of existing RFL setup that we have here, these series of attributes. They run into this multiply divide node, and then that is run into the join. So we're going to add the old setup with the new setup together using this plus minus average node. All right, so we're going to kind of go through this a little bit faster than we did in the previous video because it's mostly the same as what we did in the previous video. So we're going to take the U value here, plug it into the X value and the Y value of the set range node, since the U value is the driver. Now these settings are going to change a little bit. So the setting that happens right before you lift up from the toe is actually you lifting up from the ball joint. Because when you do the foot roll, it goes flat to ball to toe. So the ball joint, or this path ball attribute that we have here, this is actually going to go into the old min X. So there's the attribute for that. And the max point for X is going to be the toe. So let's go old max X is the toe here. And then to kind of offset that, that's what the Y value is going to be here. That's what the negative 60 is. It's going to cancel out the positive 60. So we're going to use the toe as the old min Y. And then the top of the arc is the next point. So that's where the foot's going to kind of flatten out. So we'll do path top. Now we created this condition node here to for a certain point, I believe when the offset was 10, because that's where it starts here at the top. But I don't think we're actually going to need the condition here. I think we can be fine without it. The reason we needed it for here is when the animation kind of looped around and started here, we needed it to be 0 for the heel. Well, we don't really need to worry about it starting here because this is actually where it ends. So I think we can be fine with the path top here for the old max Y. So I don't think we have to worry about any conditions for the top there. So 0.1 to 0.25, and then 0.25 to 0.5. So that seems to be working. So that's good for the basic setup at least. So let's plug this in to the on-off multiply divide. So value X and value Y into input 1X and input 1Y. Let's take the animation on-off attribute from the main foot control, plug those in to the input 2's here. And then for the plus minus average, we start with the old setup, or the existing setup for the RFL. So the output Z of this multiply divide node goes into the input 1D, 0, and then we take output X and output Y and we plug it in. So we've now added the old setup with the new, so now we just need to connect the output 1D into the rotate Z of the joint. We can delete that old unit conversion, and there we go. So it's all connected in. So that should be it for the toe. I kind of adjusted. I hate that the node editor does this now. So it kind of forced everything here. So it changed positions, but everything, there's the toe set range. So that seems to be it. Okay. So let's check just to make sure the toe is working here. So if we run this and hit play, there we go. See it lifting the toe. Looking good. And let's, this should be working with most of the offsets that we do here for the foot. So I believe this should work with 10 and negative 10. Let's see. Yep. So it works with 10. It works with negative 10 because that should be the exact same setup. And it should work with negative 5. Yep, so it's working with each one of those settings except the one where it's not going to be working is positive 5. And you can see what happens there. So this is where the toe point here of the animation arc is, this is where it's looping. So this is the 0 to 1 switch that we talked about in the previous video. So we need to create that condition node that we did similarly for the heel. We need to do that for the toe. So I'm just going to duplicate this condition node that we did for the heel. So rename this to toe condition. Let's plug these values in. So I'm going to move some of this over. There we go. Like that. It's getting a little cluttered in here, but we should be able to manage. All right, so we take the path toe attribute, plug it into the first term. So if the first term is equal to 1, then the value should be 0. It should flip to 0. Otherwise, plug, so color false, so meaning if it's not equal to 1, just use the attribute as normal. And then we are going to plug that into the set range. And so it goes 0.85 to 1, but we need to change the old min y because we're not going from 1 to 0.025. We actually want to go from 0 to 0.25. So let's take that out color R. I want to plug that into old min y. And then similarly, what we did for the previous condition is we had these sets of values here. So what we essentially wanted to do, by default, we had it set from a min y to a max y of negative 60 to kind of cancel out the 60 degrees. Well, when the toe recycles, it's actually going to flip to 0. So the 60 is not going to be there because we're going to 1, and the second the 1 goes back to 0, this 60 is going to be gone. So that's why you're getting the foot going down, is because that negative 60 is active at that point. So we want to essentially flip it so that the min y is 60 and it goes back down to 0. So that's what we did with the previous condition here. That's what these attributes are for. So that would be the min y being 60, and otherwise it's 0. So the color of true B and color if false B the color of false G and B, these are the old settings for the set range, what these are right now, and the color of true G and B are actually the new settings that we're going to put in there. So let's plug the out color G into, let me just look at this one more time. Okay, so out color G goes into min Y. There we go. And out color B goes into max Y. There we go. Now this might be another scenario where we have to save and reopen. Let's see how it looks. Yep. So even though the settings everything's connected correctly. Yeah, so this goes from 60 to 0, so this actually is doing what it wants. But you can see the settings didn't really take, so this is going to be one instance where we're going to save and reopen the scene. So we'll be right back just after we've saved and reopened everything. Alright, so we're back. So literally all I did is I just saved it, closed it, and reopened it. And so here's the settings for when the offset is at 5. It's literally all I did. I didn't change anything. I just saved and reopened. So now it's working at every possible of the milestone offsets that we have. So the toe is now officially done. So all we need to do at this point is the ball joint. And we're going to follow very similarly, same setups that we've done for the toe and the heel. Here's the ball joint, and we want looks like output Z here for the RFL. Alrighty, so we just need the same set of nodes that we did before. So we took the set range, the on-off, multiply, divide, and the plus minus average. So we're going to duplicate this, bring all this down here, make sure we rename everything. From heel to ball. Getting used to a PC keyboard. All right. So let's bring down the things that we need. All right. So when we're dealing with the set range, so the animation point right before we lift the ball, I marked as the origin. So that's why I included the origin as one of the attributes here for the ball joint specifically. So we have like a starting point for the ball joint. So the origin is going to be going into the old min x, because that's what happens right before the ball lifts up. Then we go to the ball joint for the old max x. And then for the old min y, we do the ball joint, we do path ball as well. And then the point right after the ball lifts up is the toe lifting up. So toe will go into old max y. So that looks about right. Goes from 0 to 0.1, and then 0.1 to 0.25 when the offset is at 0. So that's looking good there. Stick with the default values for now. So let's plug the U value into the set range there. And then we will connect the set range into the on-off multiply divide node. And plug the output Z of this node here into the input 1D of this plus minus average, so we can add the new setup to the old, and we'll plug output X and output Y into the other inputs, and then plug this into rotate Z. So get rid of that old unit conversion node. There we go. So we've got everything we need here. Let me just get, I don't need that anymore. What I do need is this. Okay. So this setup should be pretty much done for the basics. I'm not sure if we're going to need it for any other point. Let's take a look and see. So let's test the animation. There we go. So we got the ball working there. It's lifting up right before the toe. Now these are settings that I went with. That you can obviously change the numbers, so meaning changing, like, you know, the values of the attributes. So if you think this is starting too early or too late, you can adjust the initial values that I keyed here. So instead of 0.1, you could do something a little bit sooner. It's kind of your choice, but this is the settings I liked that I tested, and these are the ones that, you know, pretty much worked for me. So let's test it just to see how it looks with the other offsets. So if I test at 5, so it looks good at 5. Let's test it at 10. Looks good there for 10. Let's test at -5. There we go. So it looks like it works with every other offset. So we don't actually have to do that condition that we did previously. Looks like the ball kind of works regardless of the milestone points that we use for the offset. So it looks like everything else is working here. So I'm going to call the left foot at this point officially done. So what I'm going to do is I'm just going to kind of fast forward once I've done this same setup for the right foot and just show you what it looks like completely finished. All right, so we're back. I just finished the right foot. So everything we did on the left foot, I did on the right foot. Grin and I obviously know what I'm doing with this, but once, you know, as I'm not explaining anything, the whole thing probably took me maybe 15 minutes, 20 minutes tops to do like the entire thing for the right foot. And again, you can script this out if you want, so you can do it with the click of a button as opposed to, you know, building the whole thing manually. But this is what it looks like when it's all done. So if I hit play, now we've got a full animation going here on both feet. The right foot, the offset is set to 10 with the left foot being 0. So you're getting that reflected movement, but you're getting the procedural walk animation that we were going for. If you want to change the offsets, you could change, let's say, you can change this, the left foot to 5 and the right foot to -5, something like that. With all the settings in place, it should still work exactly the same. So works pretty well if you ask me. Again, stick to those milestone points, the 0s, the 5s, and the 10s. Primarily because you do want the feet 10 points apart on the offset for this to actually work correctly. But you can see the results here. You can get a procedural walk without having to animate or key anything, and especially if you script everything out, this should work with the click of a button. The real benefit to this, in my opinion, is for, you know, multi-legged characters. You know, like insects and things that have, you know, more than 2 legs. But I wanted to include these setups of connecting it to the RFL to show that this can work with a biped character with an RFL setup. So I just wanted to show you that this was possible. It's a little bit of work, but again, scripting everything out it doesn't take very long, and I think the results look pretty good. So let me know what you think, and if there's any other videos you want me to do. I have some others lined up in the future, but hope you enjoy. And as always, please like, comment, and subscribe to keep the channel going. And if you have any suggestions of any other videos you'd like to see, let me know. Thanks for watching.